Okay, welcome back. So we are going to cover the second week lecture material this time, and it's going to be divided into three parts, just like the week 1. So this is the first part of the week 2. Yeah, it took a while to cover the first week lecture, and yes, like programming is tough for someone who is really not familiar with this type of work. And the point of this course is making you more comfortable in programming by repeatedly giving you more chances to coding and programming and learning those programs. So please don't be frustrated. When I see your face in the offline course, sometimes you are really puzzled. Yes, and I feel some responsibility about that, but okay. Why don't we regroup and do the exercise, and let's make ourselves better. Let's move to the week 2. Right. Okay. So we just talked about a little bit about the better way of making a better program or better software design in the offline course. So just separate command executions are really not good, and we want to make things better by making functions so that we can just run a single command line as a function and run a multiple the commands. And also we want to make a class out of by collecting some functions, and then we can really see that for this purpose we can use this class, and under this class, inside of this class, we have these multiple functions that we can utilize for this particular purpose, right? So we want to, we kind of evolved from this separate command executions to the functions, right? And to the classes. So that's what we haven't seen the evolution of the software. And our objectives this week is that we run the object-oriented programming paradigm, and it's the basic and they learn the basics of the software design. So objectives are understanding OOP concept here, object-oriented paradigm or object-oriented programming sometimes, or object-oriented design sometimes, right? So we want to understand the object-oriented concepts, which include class, instance, which are quite familiar with from the previous lectures. And I talked about inheritance a little bit, but I didn't cover fully. So this time I'm going to do that, and encapsulation and polymorphism and so forth. And we want to see a formal representation of the software design, right? And also, we want to understand a number of software design patterns. These first two parts are really important, and we want to focus more on these two parts. And the third part, usually before this type of kind of class progress, I just sometimes skipped, or I just briefly cover this part of material. But this time I'm trying to cover fully, okay? So, but anyhow, the first two parts are really more emphasized. So here, this is a recap. Really building a software is similar to building or constructing a building, right? So we have this schematic or blueprints, right? And we have actual realized building, right? And with tools, right? And we have this schematic, and we have these buildings, and these tools help developing the realized building, right? And sometimes in the schematics, we have lobby 1 and lobby 2 and restroom and bedroom. And restroom multiple times, bedroom multiple times, right? And even lobby, we have a couple of lobbies in some times. In that case, the real goal of this schematic is including this lobby and this restroom and these bedrooms, right? And including all these room designs is a kind of goal, right? In that case, do we have to redesign this restroom all the times? Maybe not. We can just copy and paste, right? And sometimes this works fine. And bedroom, if the requirements for the bedroom, like the sides are the same and the directions are the same, like the basic layout are same, then we can just copy and paste it. Of course, sometimes we want to have some little personal taste, so we may want to paint a little bit differently, or we want to move things a little bit differently, but that's basically inherits the characteristics of the basic bedroom design or basic restroom design. So we have same roles, similar design, and different interiors time to time, more like personalized. And the software design works just like this. We have a certain functions that need to be covered in the software, and some of those functions can be copy and paste based coding. And some functions requires more elaborate codings. The thing is that if two functions have similar role and same role, similar design, then and also want some kind of different taste of the person, individualized taste, then what you can do is that we want to use the same schematics and we want to instantiate, develop it differently, a little differently. So the thing is that class to the instance. Class works like the schematics, and instance is like the realized memory element. Okay, so this is kind of the basic storyline of building software. So here, building design and software design are compared. For instance, this correctness. When we are building something, we have to meet the owner's purpose. Similarly, software design, we have to meet the client's purpose, right? And those things must be robust, right? There must be some integrity, right? And also, we have to. Sometimes there are some overloads, like as we did in the offline course, the sentiment analysis. If there are not the 200 reviews, if we have tens of thousands of reviews, then what we want to do is that we want to make our program more robust, right? And the flexibility. We want to make our buildings more flexible, right? If we want to change the building usage purpose, in the case if the layout is flexible, then we can change the purpose of the building quite easily. That's very good. In that case, the software design for future updates and expansions of the functions, we need to design it well, right? And usability and reusability. So if a function of building is met, we need 2 lobbies and 5 bedrooms and 3 restrooms, and they are all there, but in a really mazed kind of way. In that case, the usability is really bad. So we want to make it correct. At the same time, we want to make it usable, right? These are 2 important steps. And similar and same to the software design. We want to meet the client's purpose, and the client purpose should be met by easy execution, by good support to use it, right? And finally, the efficiency. Building should be easy to build, right? Cover less area, but we want to use a less space, less land use, right? And also in the software design, easy to implement and smaller size and faster executions are all important. So like good building design and good software design are kind of alike, alright? So, right. So what you want is that eventually what you are going to do is that by using your statistical knowledge and the operations research knowledge, you are going to help your clients, in the industry and service industry and so forth, right? And your end product is going to be the software solving these problems. And the software will perform some statistical analysis or operations with OR style optimizations. And from that line, your program wants to be robust, flexible, and usable and efficient, right? And the things in between the successful, right? We have this hurdle, and you are here, and here is a good design, and you have to overcome this hurdle. And often this hurdle is the complexity. What you often want to solve are complex problems. Complexity is come in when things are so mixed together, right? If you want to touch everything, like if your program needs to optimize this, and by using the optimization result, you have to do that, and from that result, you have to do some regression analysis, or you have to do some you have to calculate some probability. Then you have to do this. If you're touching in many things at the same time, then things becomes more complex. Okay. So often software turns out to be complex. They are massive in size, right? The number of lines gets longer, right? And there are interactions between modules, functions, and classes, right? You want to make things simple, and your commands line executions, like changes variable values many times. In the case, there are interactions, and you want to keep it simple, right? And you have to decide where to stop and where to implement more. So how to make things less complex? First thing that you can do is boundarize, right? You want to set up some boundary of your program. If you want to do sentiment analysis, you don't want to drag into something else, right? So you want to make your problem boundarized. Okay? And similarly, if your problem is simply the boundarized, then you can make it simpler, because then you don't want to touch anything else besides the things that matters. Okay, so simplification and abstractions are important. And what you want to do is you want to decompose your functions into several levels, right? You want to make a sub functions. For instance, if you want to do the sentiment analysis, you want to count words, and then what you want to do is count to props, and you want to multiply props, and then you get the result. Each step requires also different levels of the command executions. In that case, you want to make a function 1, function 2, function 3. And then this is the decomposed design. decomposed design. Okay? And finally, you want to do some grouping, right? If you have decomposed your task of these things like this, then you want to make things like F4 function, which executes F1 and F2 and F3 functions, and then together you can do the sentiment analysis. So what I'm talking about here is that now I suppose that you are kind of experienced in creating classes and functions. What I want to teach here is that why you want to do that, why you want to create classes, why you want to create functions, to make things more boundarized, simplified, decomposed, and grouped. These are all the reasons why I'm teaching you how to program things as functions and as classes, right? Here the catchphrase is divide and conquer. You want to make a divisions of your functions here, and then you want to group it like this, right?